Alright, a couple of things that will help us sketch this curve. First of all, I'll probably just sub in x equals 0 and you can see y would equal 0. I can see from the top there root x, so x has to be greater or equal to 0, so I'm only looking on this side here. Also, you can see from the bottom there's no real conditions on the x at the bottom, so there's no vertical asymptote. But if we did look at the limit as x gets bigger and bigger and bigger, which will win, the bottom or the top? Clearly the bottom will, because it's the square root of x squared. 9's not going to matter once we get really big. Square root of x squared is x. So you've got a root x over an x, so the bottom's going to grow faster. So y is going to go towards 0 as x gets bigger and bigger and bigger. So as x goes towards infinity. So as x goes towards infinity, we've got y going towards 0. So we've got a horizontal asymptote, so I can't really see that, so let's put that in. So as x gets really, really big, it's going to go towards that x-axis. Alright, so show that its derivative. Alright, let's do its derivative. So if we go to y, they've both got square roots, so you could get ready in index form to do calculus. So y dash, so using the chain rule, we'll put a half down here, keep this bracket, minus 1, so that's minus a half, times by, now we'll go inside and differentiate, now it's the quotient rule, so derivative at the top, which is 1, times the bottom, which is 9 plus x squared, minus differentiate the bottom, which is 2x, times the top, which is x, so it becomes 2x squared, all over the bottom squared. Alright, so up the top here we've got 9 minus x squared if we simplify that. Alright, let's see what we've got then here. So what did we want? We want it to look like this. You can see I've got the 2 on the bottom already, so that's great, using that 2 there. So I've got the 1 on 2. We need a 9 plus x squared, and if you think about it, this 9 plus x squared here is to the power of negative a half. Can you see that? So this one is to the power of negative a half, and this one is to the power of 2. So, whoops, remember we add the indices. So 2 minus a half is 1.5, so 3 on 2. So that's where we get 9, because remember we're just timesing these, so that's to the 3 on 2. We also get a root x. Where's that coming from? So if I take this x on top, it's to the power of negative, so 1 on x, and now 1 on root x. So that's where that root x comes from. Alright, so we've used all these things up. The only thing we haven't used is this at the top, which is 9 minus x squared, difference of 2 squares. So we get 3 minus x, 3 plus x. Alright, so yes, we get that dy dx, no problem. So we're just going to use that to look at this curve. Alright, so that's y dash. So a couple of things you can see from that y dash. You can see stationary points and when it's not defined. So clearly stationary points, if we look at the top, we would have x equals 3 and x equals negative 3, make y dash equal 0. But remember, we're only looking for x's that are positive. So we're looking at x equals 3. And when I sub 3 into back in to find my y value, I've got, what have I got? Root 3 over root 18, so 2 nines. So I've got 3 root 2, and I'm going to times by root 2 on root 2, which gives me root 6 on 3 2s, 6, root 6 on 6, is that right? Yep. Alright, so root 6 on 6 is our stationary point. That's going to be our stationary point. Alright, so let's just put it in, why not? So let's say it's about here, and just make up a point. So this is going to be at 3, and this is root 6 on 6. That's our stationary point. Now if I look either side of 3 for my y dash, so if I look at, for example, if I put 2 in here, that first bracket is going to be positive still. So I've got a positive and I'm times by a positive, so the top's going to be positive. Then I've got a 2, which is positive. I've got 9 plus x squared, which is positive, so that's always positive. And then I've got to the power of 3 and 2. Now I've got root x, which is also positive. So it's going to be a positive gradient in front of positive gradient. So it's going to be increasing. And then at 3, we know it's 0. So maybe I'll put in 4. So when I put in 4 into there, I get a negative in that first bracket. I get a positive here. So at the moment it's negative. At the bottom, we already know it's all positive. All right, so that'll give us a negative, so we know it's going to be decreasing. So I do know it's going to be going up, up and back down, so it's a maximum stationary point. Okay, great. So I know that. What else do I know? If I look at the bottom here, I can tell where y dash is undefined. So it's not defined, first of all, when x is negative, because you can see that square root there. So it's undefined, but it doesn't matter. We don't have any negative x's. We've already figured that out. Where else is it not defined? That's the only place. Okay, so we already knew that. So we can just have a look at what happens to y as x gets bigger. We already said that. I think we've got the asymptote in there. Yeah. So we know it's going to go like this towards 0 because that's the asymptote. So what does it do at 0? Yes, so what does y dash do as x comes towards it from the right? So as x comes this way towards 0, what is y dash doing? What is y dash doing? All right, good question. So let's have a look at our y dash up here. So as x goes towards 0, so it's getting smaller and smaller and smaller here on the bottom. So actually that bottom part is still going to win against that top part, because if you just look at the x's, it's like an x cubed and then a square root x. So it's a 3 plus a half, so it's 3.5. Whereas at the top you've just got x squared. So the bottom's going to win. So as it's winning, it's growing faster. So that y dash is going to go towards, as it grows, yes, as it grows, not as it, sorry, as the x goes towards infinity, there, our y dash is going to go towards 0. But going the other way, sorry, therefore going the other way, my dy dx is going to go towards my infinity. Yes. Oops. There we go. Infinity. So the curve looks almost vertical. So almost a vertical gradient, but not quite. And we know it's undefined at 0 as well. So we could easily just guess that without kind of bothering to really look at it. So it's going to look something like that. Yeah, I think that's it.